Hello everybody and welcome to our lecture series for Friday, April 21st. Begin with a disclaimer. I am currently sitting at my parents' house and my dad is probably single-handedly keeping Jeff Bezos, one of the richest men alive, with how much Amazon packages he has delivered. And of course I have my histrionic little butthead Ziggy here with me. So if lecture's interrupted a couple of times today by Ziggy furiously defending my parents' house from the Amazon delivery driver, I'm so sorry. You might have to hear him shriek a little bit. So with that out of the way, let's talk about our plan for the day. So we are going to start by talking about specific heat capacity. So I'll kind of remind us about the question that we left off with on Wednesday about what kind of thing could also affect heat Q. And then we will get some practice in how to calculate or quantify some amount of heat Q. And now that we know how to quantify both heat and pressure volume work, we will use those calculations to determine the change in total internal energy of some kind of system. And then we will begin our conversation about enthalpy. And just a little bit of a warning, I remember when I first learned about enthalpy, I was kind of like, I don't know, it felt very pointless to me because as you'll find, we will often say that enthalpy is equivalent to heat Q. So I do want to begin our conversation about enthalpy with just a little bit of extra context about why it is we care, because all of these thermochemical and thermodynamic properties are things that you're going to be talking about in Chem 220 in a lot more detail. So we're going to wrap up our conversation about total internal energy and then begin talking about enthalpy for today. So I will see you in our first lecture video, part 1, where we discuss specific heat capacity.